So the price of lithium and like all the raw materials and the battery cells went crazy. It doubled. Like the price of cells doubled. Price of lithium, I think, went up at almost like fivefold or like 500%. Like went up crazy numbers.
That's exactly what Elon Musk said when talking about lithium batteries, the type that's still considered the gold standard for electric cars by most EV automakers today. Elon Musk stated that Tesla will soon switch to a new battery technology by 2026 to completely replace lithium, as it's becoming increasingly inaccessible to Tesla. While the rest of the industry continues to struggle with rising lithium costs and the limitations of lithium batteries, Tesla has been quietly perfecting aluminum-ion batteries, a battery type that could be mass-deployed at scale by 2026 and even used in Tesla's most affordable EVs. What excites us about this battery is that it has significantly higher energy density than current lithium batteries, while also lasting 3 times longer, up to 30 years for a single EV battery pack. So, why did Tesla choose aluminum-ion batteries, and what are the downsides of this technology? Right now, you're about to discover exactly how Tesla's aluminum-ion battery breakthrough is bringing the lithium era to a permanent close. Welcome to Tesla Car World. How will Tesla's aluminum-ion batteries end lithium batteries? You might not know this, but even the 4680 battery that Tesla is currently producing still contains lithium and even nickel and cobalt. These are all very expensive materials, and even Elon Musk has admitted that the current 4680 battery is still more costly than those from other suppliers.
To cost parity. But currently, our 4680s are cost more than our suppliers.
Yeah, that's why up to now the 4680 battery has only been used in the Cybertruck, a high-end pickup truck. In our opinion, a good battery that's only used in an expensive vehicle is a major letdown. It would be much better if Tesla used the 4680 battery in the Model 3, Model Y, and other EVs as well. But with such high costs, that just doesn't seem possible. Most Tesla batteries today rely on lithium, which is why Tesla hasn't been able to roll out cheaper EVs. Even their goal of launching a $25,000 compact car has taken over 4 years and still hasn't happened. That's where Tesla's aluminum-ion battery cells come in. They're a total game changer, phasing out lithium batteries in 3 brutal ways that'll make you rethink everything you thought you knew about EV tech. First off, just looking at basic chemistry, lithium doesn't hold a candle to aluminum. In terms of charge density per ion, aluminum ions are way ahead because each one can carry 3 times the charge of a lithium ion. In theory, this lets aluminum batteries store more energy in the same space, which is a pretty exciting prospect. Have you ever wondered why EV batteries or electronic device batteries are so prone to short-circuiting and even catching fire or exploding? It's no coincidence. They're almost always lithium batteries. What you might not know is that one of the most dangerous issues with lithium batteries is the formation of dendrites. To put it simply, dendrites are tiny, needle-like metal crystals that can grow during charging. These sharp structures can pierce through the separator between the battery's 2 electrodes, causing short circuits, fires, or even total system failure. Dendrites are especially dangerous in lithium metal batteries or when fast charging is involved. They're the reason Tesla and other manufacturers have had to invest heavily in control measures, such as redesigning separators or implementing advanced battery management systems. And all of this just drives the cost of lithium batteries even higher. The moment Tesla's aluminum-ion battery was revealed, safety and durability were the first things that came to our minds. Based on what we've researched, aluminum ions, when operating in certain electrolytes, especially liquid electrolytes similar to those used in lithium batteries, almost never form dendrites. Studies from Stanford and other laboratories have shown that aluminum batteries can go through tens of thousands of charge-discharge cycles without forming dendrites. This is thanks to the more uniform and stable release of aluminum ions, which is significantly better than lithium ions. Fires caused by lithium batteries in EVs have always been a major concern for customers. As you probably know, the smoke released from burning lithium is highly toxic and extremely difficult to extinguish. Despite years of development and improvement, safety advancements have been marginal at best. Of course, this isn't the only reason Tesla is pursuing aluminum-ion batteries. As Elon Musk has pointed out, the bigger issue lies in the skyrocketing cost of lithium and lithium-based batteries. This price surge is largely due to overwhelming demand and limited supply, which clearly indicates that lithium is being overexploited and is becoming increasingly scarce.
Challenge on that front, then there may be a shortage of lithium.
Before we talk about the abundance of aluminum and how that could allow Tesla to achieve ultra-low costs per aluminum-ion battery cell, we first need to understand just how serious the lithium shortage really is. As of now, the total global lithium reserves stand at around 89 million tons. In contrast, aluminum reserves are vastly greater 1.59 billion tons, which means aluminum is nearly 18 times more abundant than lithium. The geographic concentration of lithium makes things even worse. Most of the world's lithium is confined to just 4 countries. China holds the second largest lithium reserves, accounting for about 16.5% of the global total. The rest is mainly concentrated in the so-called lithium triangle: Chile, Bolivia, and Argentina. On the other hand, aluminum is the most abundant metal in Earth's crust, making up about 8.13% of its total weight. Bauxite, the ore used to produce aluminum, is widely distributed across dozens of countries, making aluminum much more accessible and less vulnerable to geopolitical risks or supply chain disruptions. Okay, let's dive deeper into aluminum-ion batteries. In an aluminum-ion battery, the anode is made from pure aluminum metal, which serves as the source of aluminum ions during discharge. On the flip side, the cathode is where aluminum ions are stored during charging and then released back when the battery is in use. Common cathode materials for aluminum-ion batteries include graphite and other layered conductive materials, which are ideal for absorbing and holding aluminum ions effectively. Connecting the anode and cathode is the electrolyte, a liquid or gel-like solution that allows aluminum ions to move freely between the 2 electrodes. This flow is what enables smooth, stable, and safe charge-discharge cycles. What's striking about aluminum-ion batteries is that they don't require any expensive materials. No lithium, no cobalt, no nickel, just aluminum, graphite, and a suitable electrolyte. Tesla plans to manufacture this battery entirely in the U.S. at a newly expanded facility adjacent to Giga, Nevada. The production line is expected to begin operation by the end of this year, once all equipment has been fully installed and calibrated. Lithium prices have been highly volatile over the past 2 years, sometimes dropping, but more often surging. As Elon Musk once pointed out, lithium prices have spiked by as much as 500%. In 2024, the average price of lithium carbonate was around $8,000 per ton, and by February of this year, it had climbed to $9,271 per ton. And that's not the whole picture. In addition to lithium, most lithium-based batteries also require cobalt and nickel, 2 other materials that are even more expensive than lithium in many cases. This is one of the key reasons why EV battery prices have remained high and why affordable electric vehicles are still financially out of reach for the average consumer. Of course, cost is only one part of the equation. The other equally important factor is performance. It's no accident that lithium batteries have been considered the gold standard for decades. Despite their safety concerns, lithium batteries have proven themselves with consistent, reliable performance, which is why they've remained dominant for so long. Why will aluminum-ion batteries surpass the performance of lithium-ion batteries? When Elon Musk decides to invest in a new type of battery, cost is a top priority. But clearly, it's not the only consideration. Aluminum-ion batteries also have to meet performance standards under real-world testing. And as we mentioned earlier, aluminum-ion batteries have an advantage when it comes to basic chemical properties. Aluminum ions carry a +3 charge, while lithium ions carry a +1 charge. This means that in theory, aluminum-ion batteries can store more energy in the same amount of material compared to lithium-ion batteries. Lithium-ion batteries have been stuck at a theoretical maximum energy density of 250 watt-hours per kilogram for decades. But Tesla's breakthrough with aluminum-ion batteries has shattered that limit, reportedly achieving over 600 watt-hours per kilogram in real-world test results. To put that into perspective, the current Tesla Model Y long-range RWD has a driving range of 357 miles, using a 75 kilowatt-hour lithium-ion battery pack. If that same battery pack were replaced with aluminum-ion tech while keeping the same size, The Model Y could potentially reach a range of over 1,000 miles on a single charge. Sounds unbelievable, right? A 1,000-mile range might seem like an exaggerated scenario, but it's something that could very well happen soon. The reason is simple. When a high-energy density battery is used in an electric vehicle, the higher the energy density, the lower the overall weight of the battery. And with less weight, the car benefits from better aerodynamics. About lifespan. While lithium-ion batteries typically last around 2,000 charge cycles before dropping to 80% capacity roughly 3 to 5 years of daily use, several non-Tesla research reports have shown that aluminum-ion batteries can reach up to 10,000 cycles. That means they could last up to 30 years with proper vehicle maintenance. As we all know, aluminum is a highly durable material. Most modern car frames are made of aluminum. It's also chemically more stable than lithium. Unlike lithium, which reacts easily with oxygen and water, aluminum forms a natural oxide layer when exposed to the environment. This protective layer prevents corrosion and degradation of the anode material. And, as we've also pointed out, dendrite formation. A major issue in lithium-ion batteries is nearly non-existent in aluminum-ion batteries. This alone significantly reduces electrode degradation across thousands of charge-discharge cycles. Over the years, lithium battery technology has made notable progress in charging speed from taking several hours to now reaching 80% in just 25 to 35 minutes. However, that still doesn't come close to the breakthrough speed offered by aluminum-ion technology. With aluminum-ion batteries, you can fully charge the battery in just 15 minutes without running into thermal issues, which remain a major drawback of lithium. The science behind this is truly impressive. Aluminum ions travel through the electrolyte up to 3 times faster than lithium ions, and their thermal management capability is far superior. This effectively eliminates the heat-related issues that complicate lithium charging. Charging your EV could soon take no longer than enjoying a cup of coffee thanks to aluminum-ion batteries. Currently, producing lithium costs between $55 and $100 per kilowatt-hour, while aluminum production only costs around $15 to $25 per kilowatt-hour, using standard aluminum processing techniques. Aluminum itself is about 1/50th the price of lithium per unit, and the manufacturing complexity is significantly reduced thanks to the already well-established global infrastructure for aluminum processing. To put it simply, a 63 kilowatt-hour battery pack for a Tesla Model 3 currently costs around $6,300 to $6,500, but with aluminum-ion batteries, that cost could drop to just around $2,000. This single change, alone, dramatically reduces the total production cost of an electric vehicle. Another major advantage is the recyclability of aluminum-ion batteries. As one of the most abundant materials on Earth, widespread adoption of aluminum-ion batteries could help address the environmental challenges related to rare earth metal mining and battery recycling. Researchers have found they can recover up to 80% of aluminum fluoride salts in lab experiments, and they anticipate much higher recovery rates at industrial scale. The solid aluminum foils can also be reused after simple surface cleaning, making the entire design well-suited for efficient component recycling. While aluminum-ion batteries are promising and have the potential to revolutionize not only Tesla, but the entire EV industry, it's important to acknowledge that every new technology comes with challenges and drawbacks, and these take time to overcome. One of the major hurdles aluminum-ion batteries still face is lower output voltage compared to current lithium-ion batteries. Specifically, today's aluminum-ion cells produce around 2.65 volts, whereas lithium-ion cells can reach around 4 volts. Although aluminum-ion batteries are highly promising and have the potential to revolutionize not only Tesla, but the entire electric vehicle industry, the undeniable reality is that any new technology comes with challenges and drawbacks, and these take time to resolve. Aluminum-ion batteries still face several key obstacles that hinder their widespread adoption in real-world applications. One of the most significant challenges is their lower output voltage compared to today's lithium-ion batteries. Specifically, Current aluminum-ion batteries generate around 2.65 volts, whereas lithium-ion batteries can reach up to about 4 volts. This voltage difference can have a major impact on the performance of applications that require high voltage, such as electric vehicles and large-scale energy systems. Lower voltage may reduce the suitability of aluminum-ion batteries for devices or vehicles that demand strong and stable power output, limiting their usability in today's industrial sectors. Innovating energy storage technology is crucial for a more energy-efficient and sustainable future. As the world shifts toward clean energy, the demand for safer, longer-lasting, and more cost-effective batteries is growing rapidly. Aluminum-ion batteries stand out as a promising solution, offering much faster charging and significantly better capacity retention compared to traditional lithium-ion technology. These batteries can potentially recharge fully in just 15 minutes, endure up to 30 years of use, and deliver a driving range of up to 1,000 miles per charge, all without the fire risks commonly associated with lithium. Their environmental and economic advantages are just as compelling. Aluminum is far more abundant, affordable, and easier to refine than lithium, making the production process less harmful and more scalable. This is the kind of disruptive potential Elon Musk hinted at when he said everything would blow up next year, not in a literal sense, but as a massive leap forward that could redefine not only Tesla, but the entire battery and EV industry. What do you think about aluminum-ion battery? Drop a comment below. The line between humans and machines is about to blur, where sci-fi dreams are no longer fiction. We dare to bet on it, and you might already feel it too. What we thought was impossible just a decade ago is now clearly here. AI has entered the real world. More precisely, Tesla bought version 3, Optimus Generation 3 in the real world. This isn't just an ordinary machine, it's a pinnacle of technology, a direct challenge to the future itself. Not only has it proven capable of performing previous homemaker tasks, but Elon Musk has also confirmed the integration of Grok Voice into Tesla Bot version 3. This unlocks a wide range of new utilities and features for Optimus. Just imagine, a robot that talks to you like a close friend, thanks to the integration of Grok Voice AI from xAI, artificial intelligence that allows Optimus Gen 3 to communicate in a smooth, shockingly natural way. Musk has also confirmed that the new version of Optimus will feature many improvements over the current one, and that a production line for 5,000 robots is already in motion. Tesla is the first company to make this happen. It's both thrilling and a little scary to think we'll soon encounter these robots anywhere. But this is the future Elon Musk is aiming for, just like how he made electric vehicles mainstream with Tesla. There will be both positive and negative impacts, but one thing is certain. Optimus is opening the door to an entirely new world. So what's new in version 3? When will it launch? There's no denying that Tesla's Optimus robot is one of Elon Musk's most ambitious projects to date, with billions of dollars being poured into its development. You might still question its usefulness after all. It hasn't yet proven enough to be truly convincing. The tasks it performs are relatively simple, and as engineers have acknowledged, Optimus still has a long way to go in terms of refinement and debugging before it's ready for sale next year. Currently, at least 4 major upgrades are in development for Optimus, and completing them will pave the way for the release of the final version, Optimus Gen 3, or version 3, as Elon Musk has referred to it. To prove that Tesla is more than just a leading EV company, it needs to deliver a product that goes beyond EVs, and that's exactly why Elon Musk is now putting so much focus on the Optimus robot. Alright, let's dive deeper into the game-changing integration of Grok Voice AI into Tesla's Optimus version 3. As someone who's been tracking the evolution of humanoid robotics, we can tell you this move puts Optimus in a league of its own, and here's why. First off, the natural language capability of Grok Voice is a massive leap forward. Unlike traditional voice assistants that rely on rigid command sets, Grok, powered by xAI's cutting-edge AI, enables Optimus to engage in fluid conversational exchanges. It can use voice to deliver information to users more quickly, especially for elderly people who need to look up information and are accustomed to listening to news through voice. From the very beginning, Elon Musk shared that Optimus could be especially beneficial for both the elderly and children, thanks to its wide range of extended utilities. Optimus can quickly answer questions using its super-intelligent AI brain, and it can serve as an in-home tutor for children, effectively supporting their learning. It's also perfectly suited to assist seniors in using smart home devices. You can simply say, "Hey Optimus, tell me how to use the iron," or "Optimus, please show me how to use a smartphone," and the Tesla bot will patiently explain it to you until you understand. This is truly one of its key advantages with Grok Voice. Second, the adaptability of Grok Voice shines in diverse environments. With support for multiple languages and real-time contextual understanding, Optimus can operate seamlessly in noisy industrial settings or multilingual households. This is a big deal. Most competing robots, like those from Boston Dynamics, rely on pre-programmed responses or limited voice recognition, which falter under variable conditions. Optimus, however, can filter out background noise and prioritize user input. The clearest evidence was when Tesla brought 50 robots to the We Robot Cybercab launch event last October. Despite the crowd gathering around and the somewhat noisy background music, Optimus still delivered responses and comments that delighted most attendees. This proves that it can still hear, analyze commands, and provide answers even in noisy environments. With Grok Voice, this integration positions Optimus as a premium offering. The high cost Musk alluded to likely reflects the advanced tech stack, but it's justified by the unique value, personalized interaction, environmental resilience, and continuous improvement. Compared to competitors like Figure AI or Agility Robotics, which focus on physical dexterity without such sophisticated AI, Optimus version 3 becomes a holistic solution. So far, 3 versions of the robot have been released. Even though Tesla only began the project just over 2 years ago, that's a remarkable feat no other company has managed to achieve. In terms of design, we believe the Tesla bot is currently the most aesthetically pleasing robot out there. When placed next to other robots, the difference in refinement is striking. While other robots often expose wiring, metal frames, and heavy-looking components, Optimus features a seamless design with no visible flaws. From our perspective, the only improvement it might need at this point is a front-facing display screen. However, that's just our opinion. Of course, for Tesla, adding such a feature might be unnecessary. It could complicate development and increase the cost beyond the target price of $20,000. What's surprising, though, is that even with such a polished design, this isn't the final look Tesla is aiming for. Musk has repeatedly emphasized that the design of Tesla version 3 will be something truly special. Just last week, he posted on X, "So many improvements to come in the next design of Optimus." So, what do you think Tesla would change if they were to redesign the current Gen 2 model? Honestly, it's hard for us to guess. There are few, if any, flaws in the current design of Optimus. It features a head with multicolored LED lights to indicate status, such as low battery or active operation, the word Tesla printed on the chest, a striking black and white color scheme, and even a special Optimus Golden version, inspired by the Cybercab. Yeah, the Tesla bot really has a clean and minimalistic design, which makes sense for the $20,000 price point. If Tesla made things more complex, we bet the price would go up significantly. However, according to Elon Musk, redesigning the bot isn't about making version 3 more luxurious or premium. It's about making it easier to mass produce. Musk wrote on X, "The toughest part by far is improving the design of Optimus for ease of manufacturing and tooling up a complex supply chain, so it can be made in significant numbers." So for version 3, redesigning the bot will be the very first upgrade underway, and we'd bet it will go far beyond what anyone expects. It's shaping up to be a jaw-dropping transformation compared to the current Gen 2. As we've mentioned many times in earlier episodes, version 3 of Optimus is expected to feature a 22 degree of freedom hand, replacing the current 11 degree of freedom version. But let's put the technical side aside for a moment and talk about design. As we've all seen, the 22 degree of freedom hand of Optimus is nearing design perfection. You can compare it directly in the video where Optimus catches a tennis ball on the left is the next-gen hand, while the right side still uses the older version. The older hand still exposes some cables and actuators, while we were genuinely stunned to see how the new hand is almost completely enclosed. We mean, there's nothing visibly sticking out anymore. Even the fingers don't show prominent joints like the older version. Yes, that's the design part. When looking at the new hand, the first thing that came to our mind was that Optimus might now be able to do tasks like washing dishes or even doing laundry. The new hand appears to be much more water-resistant than the old one. They almost look like they're covered in gloves, possibly a direct answer to those who've questioned whether Optimus could handle tasks involving water. Moving on to the technical and functional aspects of the new hand, we've all read and heard Elon Musk's bold claims that it could thread a needle, play the piano, or even perform more complex tasks. Sounds hard to believe, right? But after closely observing the new hand's performance in the demo video, we now understand why Musk is so confident. It's clear that the new hand allows for much more precise finger manipulation. The joints bend easily, almost like a human hand. The Gen 2 Optimus hand had 11 degrees of freedom, but the upcoming one has 22, just 5 short of a human hand, which has 27. To put it simply, even with just 11 degrees of freedom, Optimus was already able to fold clothes, water plants, hold eggs without breaking them, install small electronic components, carry battery trays, and even serve drinks. And that was just the beginning, considering both the brain and the hands of Optimus were still in a fairly early stage. With the new hand in version 3, Musk believes Tesla Bot will pull far ahead of its competitors and become the most advanced humanoid robot in the world. 100, 500, or even thousands of tasks could potentially be handled by this robot. Of course, Tesla had to overcome major challenges to achieve this, because nearly 50% of the robot's overall mechanical complexity lies in the new generation of hands. When observing Tesla Optimus's walking posture, many people have humorously compared it to someone finishing an exhausting leg day at the gym. Others joked that Optimus walks like a president stumbling across a stage. While these comments may seem like lighthearted fun, they actually point to a noteworthy issue. Optimus's gait is still quite limited, and Tesla knows it. Elon Musk has repeatedly emphasized that improving mobility speed is one of the top priorities in the development of Tesla Bot, with the long-term goal of reaching speeds up to 5 miles per hour. That said, if we look at the progress made since the beginning of the year, there have been clear improvements. Optimus has gone from an unsteady, wobbly walk to a more balanced and consistent stride. Still, in our view, its speed and confidence in movement aren't yet convincing enough to be called a breakthrough. Tesla still needs a major leap forward in motion control technology if it wants to bring Optimus up to the level of robots like Boston Dynamics' Atlas or Kepler's Forerunner. Interestingly, the slightly bent knee walking posture we see in Optimus isn't a design flaw. It's actually an intentional choice. This stance helps lower the robot's center of gravity, which improves its balance, especially when navigating uneven surfaces or unexpected situations. At the We Robot event, Optimus demonstrated this advantage by moving smoothly through a crowd in low-light conditions. That said, in terms of speed, Optimus is still trailing behind. With an average walking speed of about 2.2 miles per hour, compared to some competitors reaching 3 miles per hour, there's still work to be done. Tesla's latest update to Optimus's gait shows a more natural movement, with less of the hunched-over posture that led to earlier jokes, comparing it to Joe Biden's walk. So it's clear Tesla is continuing to refine Optimus's mobility through hardware adjustments, weight distribution, and battery improvements. Speed might be a current weakness, but with version 3, Optimus is almost certain to surprise us. In case you didn't know, Tesla's strength doesn't just lie in its technology. When the company decided to build a product outside of electric vehicles, it had to recognize its unique edge over the competition. Because in the world of robotics, technology alone, knowledge, experience, and expertise isn't enough to dominate, especially for a company rooted in the auto industry. That's why Tesla is leveraging two major advantages: its massive logistics network and its ability to repurpose EV components for use in robots. This strategy allows them to build a sophisticated robot while also scaling production at a level most companies can't match. Musk has stated the goal is to eventually produce billions of robots, and that's exactly the direction they're heading. Of course, things can't move that fast right from the beginning, especially with a robot like Optimus, which is still being built by hand. At the moment, it doesn't have an automated production line like Tesla's EVs do. The engineers working on the project are still manually building and assembling it in small quantities. We find it kind of funny that many people think a Tesla bot could build another Tesla bot. While that's technically possible, it's definitely not the case right now. To manufacture millions of Optimus units per year, an automated production line will eventually be necessary. All the components like the battery, actuators, frame, cables, and cameras will need to come together in one area, and specialized machines will assemble them very quickly. Optimus operates on a system similar to Tesla's vehicles, meaning it makes real-time decisions instead of just performing pre-programmed actions. Right now, it relies on remote control for training and data collection, something that often leads to confusion and skepticism among those who don't fully understand the robot development process. Some people think Optimus is just a robot that walks like Biden and isn't autonomous, as Tesla claims, once they find out it's being remotely operated. But that idea is ridiculous because even we, as humans, need to learn and practice skills before we can perform them well. You can't be good at something right away. Everything takes time and training before you can do it effectively on your own. Optimus is no exception. That's why Elon Musk emphasizes that Optimus will be fully autonomous by next year. With plans to deploy thousands of robots in factories next year, Optimus isn't the kind of robot that just repeats a single task. It's much more versatile. It can observe its surroundings, analyze machinery, production areas, and information systems, and make decisions based on the situation, all in real time. That's why many of the tasks for Optimus are expected to roll out as early as next year. Deploying Optimus in factories is one of the boldest moves no one else dares to try except Tesla. Neural networks are one of the most critical areas where Tesla excels, which is why Elon Musk is especially confident that they have the best robot brain in the world. Optimus uses an advanced neural network developed with similar technology to Tesla's full self-driving system, which has been refined to support autonomous driving. This neural network is integrated into a custom AI chip that processes data from sensors, cameras, and navigation systems to perceive the environment, plan movements, and interact with objects. One standout feature is that Optimus can operate using a single end-to-end neural network, meaning it can handle a wide range of tasks, from walking and picking up items to doing household chores, all through one unified model. This network is trained on real-world human video, including first-person perspectives, and may eventually expand to learn from internet video as well. For example, recent demos show Optimus learning to vacuum, stir food, or pick up objects just by analyzing visual data, proof of its ability to learn and adapt quickly. In addition, the neural network allows Optimus to maintain balance and move across uneven terrain, even when it's blind visually, thanks to other sensors and ultra-fast processing speeds. Tesla Bot now capable of learning up to 100 new tasks per day simply by watching videos. Whether it's cooking, cleaning, or sorting factory parts, Optimus absorbs knowledge at a rate far beyond human capability. Unlike older robots that required manual programming or teleoperation, Optimus uses a neural network trained on real-world video data, similar to how Tesla's full self-driving learns from millions of hours of driving footage. This allows Optimus to observe a task, simulate it in a virtual environment, and perfect it before applying it in real life. Once a robot masters a skill, the knowledge is instantly shared with all other Optimus units through Tesla's collaborative learning system. If one robot learns to make an omelet, every other robot can do it too. This exponential learning model means Tesla could build a massive skill library faster than any human workforce. Optimus can now perform complex two-handed tasks, respond to simple voice commands, and handle coordination far beyond earlier versions. With an 8-hour battery powered by a 2.3 kilowatt-hour pack, it's designed for practical use in both homes and factories. However, the rise of such fast-learning AI raises concerns. What happens if Optimus watches a dangerous video? Could it replicate illegal or harmful actions? While the potential is immense, so are the ethical questions. Still, Musk believes this robot will be Tesla's most important product yet, with demand outpacing anything they've ever made. As we move into an era of shared intelligence and task automation, Optimus is not just a machine, it's a glimpse into the future of labor, learning, and possibly humanity itself. Once heavily criticized and the subject of countless negative discussions, Neuralink is undoubtedly the most controversial technology among all of Elon Musk's ventures. Unlike Tesla or SpaceX, Neuralink is seen as carrying serious risks, ranging from medical safety and ethical concerns in research to privacy and security issues. The idea of implanting a chip into the human brain has yet to win over the trust of the general public. However, over just the past year, Neuralink has truly stirred global attention with 7 successful human implant cases that delivered stunning results. Even former critics and skeptics have had to admit that Neuralink is changing the game. It's now being hailed as the most promising hope for patients suffering from paralysis, loss of mobility, or an inability to communicate. And recently, Elon Musk unveiled some truly mind-blowing updates about what's happening behind the scenes and what's coming next in their experiments. So, is Neuralink about to revolutionize everything? When Elon Musk took the stage at Neuralink's recent presentation, he didn't just give a status update. He painted a vision of the future where humans merge with machines, break past biological limitations, and explore the very nature of consciousness. Musk declared that Neuralink is building a general-purpose brain-computer interface capable of transmitting data into and out of the brain at megabit or even gigabit levels of bandwidth, compared to just 1 bit per second when we speak or type.
Our first product is called telepathy, and that enables someone who has lost the ability to command their body to be able to communicate with a computer and move the mouse and actually operate a computer with roughly the same dexterity, ultimately much more dexterity than a human with working hands.
As we all know, Neuralink's first-generation chip, called the N1, is part of the telepathy project. This chip mainly focuses on restoring basic motor functions that patients have lost. For those who have had the telepathy chip implanted in their brains, they can now control a computer, play video games, or even design 3D products using only their thoughts instead of their hands like the average person. But Musk's ambitions don't stop there. He has claimed that Neuralink will restore sight to those born blind through a project called Blind Sight.
Our next product is Blind Sight, which will enable those who have total loss of vision, including if they've lost their eyes or the optic nerve, or maybe have never seen, were blind, even blind from birth, to be able to see again.
Neuralink also helped deaf individuals hear again by stimulating the auditory cortex, and even allow users to merge with Tesla's Optimus robot, controlling the robot's entire body as if it were a second physical form. Sounds unbelievable, right? But that's exactly what Neuralink is working on. Now let's talk about the 7 patients who have received Neuralink implants. As of June 2025, Neuralink has implanted the N1 chip in 7 patients with varying conditions, 4 with spinal cord injuries, and 3 with amyotrophic lateral sclerosis as part of the PRIME study at the Barrow Neurological Institute in Phoenix. All devices have been stable, with no serious failures reported, and users have been using the BCI for an average of 50 hours per week at home, some as much as 100 hours or more, demonstrating deep integration into daily life.
Yeah, I'm Nolan, aka P1.
Nolan Arbaugh, the first patient to receive the implant in January 2024, is a living testament to the potential of telepathy. A quadriplegic from a diving accident, Nolan has broken the world record for BCI control at 9 bits per second, using his thoughts to control a computer cursor, playing Mario Kart, learning math, writing, and working from 6 a.m. to 11 p.m. Despite the problem of 85% of the electrode threads shrinking as a malfunction in the early days of the implant, the Neuralink team immediately improved and fixed the software to maintain the original performance, which also partly proves the team's ability to quickly overcome technical problems.
My name's Alex. I am the second participant in the Neuralink study.
Alex, the second patient to receive Neuralink's implant, he is a former auto technician who became quadriplegic after a car accident. Before the implant, he relied on a quad stick, a mouth-operated joystick to play games or interact with a computer. However, the device had serious limitations, especially in fast-paced games like Counter-Strike 2, where moving and aiming simultaneously was nearly impossible. In July 2024, Alex underwent surgery to receive Neuralink's Link device. The procedure was refined to avoid the electrode retraction issue that occurred in the first patient, Noland. In a surprising turn, just 5 minutes after connecting the device, Alex broke a world record in BCI-based cursor control. Now, Alex plays Counter-Strike, 2 more smoothly by, aiming with his thoughts and moving with the quad stick, resulting in what he described as an incredibly fun experience. On day 2 after the implant, he fired up Fusion 360 CAD software to design a 3D printed stand for his Neuralink charger, marking his return to his passion for design. But it didn't stop there. Perhaps even more impressive, Alex regained the ability to handwrite after 4 years of paralysis. He used a robotic arm to write the word convoy, draw a logo, and most recently, control a real-world Optimus robotic hand using his neural signals. Another major step toward Musk's long-term vision.
Let's say somebody has lost their arms or legs. We could actually attach an Optimus arm or Optimus legs.
Next is Brad Smith, the 3rd Neuralink patient, who suffers from ALS, a disease that gradually robs a person of muscle control. Smith is completely paralyzed, able to move only his eyes and a small part of the corner of his mouth. He relies entirely on a ventilator to stay alive. Before receiving the implant, he used eye tracking technology to communicate, but it was slow and ineffective under bright lighting, limiting his ability to interact socially. In November 2024, Smith officially received his Neuralink implant. Neuralink has profoundly changed Smith's life, giving him a level of independence and communication speed he never had before. He can now type on a MacBook Pro using a virtual keyboard and even edit videos. A notable milestone being a YouTube video published in April 2025, which may be the first video edited using a BCI. Using recordings of his past voice, Neuralink and AI, including xAI's Grok 3, recreated his voice, allowing him to speak through text, making conversations feel more natural. Smith has used Neuralink to watch his son compete in robotics, chat with neighbors, and give talks at his local church. He's also working with Neuralink to develop an AI-powered chat app that speeds up response time in conversations. While brain-based typing is still slower than thought, he's testing optimized keyboards and editing tools to improve efficiency. Mike and RJ are the 4th and 5th patients in the telepathy project. Mike received his implant in February 2025 after being diagnosed with ALS, which had taken away his muscle control. He was previously a survey technician for the city government, but ALS forced him to stop working. Once again, Neuralink brought a miracle to this man's life. Thanks to Neuralink's N1 implant, Mike is able to control CAD software using only his thoughts, allowing him to work remotely and continue providing for his family. He is the first person to use Neuralink to maintain full-time employment, demonstrating the potential of brain-computer interfaces to restore productivity and financial independence. Mike controls the computer cursor to perform design tasks, similar to Alex. Despite the challenges of ALS, Mike has leveraged the technology to preserve his sense of purpose and contribute his professional skills, playing a key role in the PRIME study, which evaluates the safety and functionality of the implant. RJ, the 5th patient, is a U.S. military veteran who received his implant this April at the University of Miami as part of the PRIME trial. He became paralyzed due to a spinal cord injury from a motorcycle accident, losing the use of his hands and becoming dependent on others. The surgery, which used the R1 robot to implant the N1 device, went smoothly, and RJ was discharged just 1 day later. Neuralink now enables him to control a computer and smartphone with his mind, unlocking activities like gaming and managing smart home devices. In a recent video, RJ plays Call of Duty, executing commands like movement and shooting using only his thoughts, offering a gaming experience he hadn't been able to enjoy before. He also turned on a TV for the first time in over 2 years, marking a major step toward independence. RJ described Neuralink as having restored light, motivation, and purpose, inspiring future patients. His surgery represents a milestone for the University of Miami and strengthens its role in BCI research. The remaining 2 patients, although less information is available about them, have also been confirmed to be successfully using the device. Looking ahead, Neuralink is accelerating new projects with an ambitious roadmap over the next 3 years, aiming to tackle various neurological disorders and enhance human capabilities. One of those projects is Blindsight, expected to begin trials within 6 to 12 months between mid-2025 and early 2026. Elon Musk has promised to restore vision for congenitally blind individuals by implanting the S2 chip into the visual cortex. Users will wear glasses with built-in cameras that capture scenes from the environment and transmit signals to the brain to generate visual images. Musk claims Blindsight could one day deliver superhuman vision, enabling users to see radar, infrared, or ultraviolet, though it will initially start with low-resolution imagery. Neuralink has built a medical imaging facility equipped with a Siemens scanner and has scanned the brains of 50 people to map the visual cortex, ensuring precision for implant placement. However, recreating complex visuals requires millions of channels, far beyond current hardware capabilities, and implanting deep into the calcarine fissure carries a higher risk of damage. Another upcoming project focuses on speech decoding, targeted for launch in the third or fourth quarter of 2025. It involves implanting devices into the brain's language centers, specifically the Broca's and Wernicke's areas, with the goal of restoring or enabling natural communication. This would allow individuals with ALS or stroke survivors to speak directly from their thoughts, generating text or synthetic speech, potentially revolutionizing communication. The main challenge lies in the complexity of language, which demands a much higher number of neural channels, and adaptive machine learning algorithms to interpret the constantly shifting brain signals. Neuralink is also targeting deep brain treatments, implanting electrodes into folds in the limbic system to address conditions such as depression, anxiety, neuropathic pain, or Parkinson's disease. Alex made history by using brain signals to control a real Optimus robot hand, performing everything from basic movements to playing rock, paper, scissors on screen. This marks a leap beyond controlling virtual robot arms for writing or designing. Musk envisions a future where paralyzed individuals could inhabit Optimus to work, explore hazardous environments, or live independently. It's truly unbelievable. After hearing Musk talk about this, a series of thoughts flashed through our minds, and it seemed like hope for people with disabilities is becoming clearer than ever. Hard to believe, but Musk explained this in great detail. Here's how it works. In a healthy person, neural signals from the brain allow us to move our arms, legs, and perform other sensory functions at will. However, in the case of attaching Optimus parts, when a patient completes the Neuralink chip implantation and integrates Optimus components into their body, the neural signals from the brain, normally transmitted to biological limbs, would instead be directed to robotic limbs. This enables users to control and operate these robotic limbs as seamlessly as their real ones. We don't want to talk too much on the connection between Optimus parts and the Neuralink brain implant chip, as there are clearly aspects we can't fully grasp without delving deeper. We are only sharing what Elon Musk has explained and the most straightforward concepts. Yes, Elon Musk actually referred to this as a superpower, because he believes controlling Optimus's robotic arms and legs will be more flexible and responsive than regular biological limbs. The latency when using Optimus components is expected to be minimal. As we know, Optimus is now able to talk and communicate quite well. At the We Robot event in October, it was able to answer questions from the attendees. So we believe that not only patients who have lost limbs, but also those who have lost the ability to communicate could have conversations through Optimus. The Neuralink chip will transmit your thoughts to Optimus, which will then encode and analyze them, allowing it to speak on your behalf. Tesla Optimus will have the ability to engage in conversations and customize its language model based on the user's personality, habits, and preferences. Especially with the integration of Neuralink, those who struggle with speaking will be able to communicate more easily through Optimus. How would you feel if your thoughts were expressed through the voice of the Optimus robot? We had never considered this possibility before, but after Elon Musk mentioned it, we believe it's entirely feasible. How would you feel if your thoughts were expressed through the voice of the Optimus robot? This is something we never imagined before, but after Elon Musk brought it up, we believe it's entirely possible. To put it simply, the process begins with implanting a special chip with electrodes thinner than a human hair to capture electrical signals from the brain. Unlike other implants, this chip is placed in brain regions responsible for language and communication. The electrical signals recorded by the chip are then sent to a signal processor, which uses machine learning algorithms and artificial intelligence to decode them into commands or language. Once decoded, these signals can be converted into text. For example, if the user thinks of a specific sentence, the system recognizes and translates those signals into corresponding text. A text-to-speech system will then be used to convert the text into speech. Modern TTS technologies are already capable of generating natural and clear voices. This is where Optimus plays a crucial role. Equipped with an internal speaker system, it can vocalize the processed speech just as it is demonstrated in past interactions. Although there may be a slight delay between when a patient begins to think and when the speech is produced, Tesla is undoubtedly working toward minimizing this lag and enhancing real-time communication. Neuralink's report states that, combining the participation time of all 3 patients in the PRIME study, a total of 670 days have passed, with the patients collectively using telepathy for over 4,900 hours. These hours include both scheduled research sessions with the Neuralink team and independent use for daily activities. The independent usage highlights how practical the link is for real-world applications and demonstrates the company's progress toward its mission of restoring autonomy. Last month, participants used the link independently for an average of 6.5 hours per day. This is a positive outcome that demonstrates the durability of the Neuralink chip, even in the face of the human body's natural biological rejection mechanisms. So far, no additional health concerns or implant malfunctions have been reported. On the contrary, the 3 patients have continued to expand their capabilities, becoming more productive, earning income, and relying less on their families. These are truly encouraging developments that help build greater public support for Neuralink. It's something well worth backing. Neuralink is still recruiting patients with ALS or spinal cord injuries for its ongoing trials in the U.S. Most implant procedures are conducted at the Barrow Neurological Institute in Phoenix, Arizona, and the University of Miami, Florida. The company has also expanded its research into Canada and is in the process of setting up trials in the United Kingdom. It is estimated that around 180,000 Americans are living with quadriplegia, with approximately 18,000 new spinal cord injuries leading to this condition each year. In a society where technology and digital tools play a central role in work, entertainment, and social life, individuals with paralysis often struggle to fully participate. The inability to conveniently use technology isolates them, reduces their independence, and creates significant financial barriers. Neuralink addresses this issue by enabling them to control computers, smartphones, and smart devices using only their thoughts, helping them reintegrate into society and regain autonomy in their daily lives. Beyond personal benefits, Neuralink's impact extends to society as a whole. This technology can help paralyzed individuals regain career opportunities, allowing them to contribute their intellect and skills without being limited by physical mobility. With the ability to use computers efficiently, they can work in various fields such as graphic design, programming, scientific research, and remote creative roles. This not only brings economic benefits, but also reshapes society's perception of people with disabilities, from individuals in need of assistance to active contributors who can thrive alongside the community.